Hello everyone, welcome back to RS Academy and today we'll be learning physics, laws of motion and I'll be teaching you the derivations along with the problems in the next video. So stay tuned and in this video we'll be seeing the concepts of the complete lesson. So come let's get started. Now imagine you're standing inside a bus. Okay. So suddenly the driver starts the bus. Your body jerks backwards and a few seconds later, the driver suddenly applies brake. Now your body jerks forward. Why does this happen? Did someone push you? No, because this is simple daily observation became the foundation of modern physics. Okay. Now today we'll be seeing why bodies move, why bodies stop, how force changes motion, why friction exists, why rockets launch, and why planets revolve. So all of these comes under one chapter called laws of motion. Okay. Let us start with displacement, velocity, and acceleration. Okay. Now, what is displacement? Displacement is a change in position of an object. So, what is the formula of displacement? Displacement is equal to final position minus initial position. What is the unit of displacement? Meter. And now, displacement is a vector quantity. It has both magnitude and direction. Okay. And next, let us see about velocity. What is velocity? The rate of change of displacement with time. Right? Now, what is the formula of velocity? Delta x divided by delta t. What is v here? Velocity. And what is delta x here? It is displacement. Okay. And what is t here? Time taken. And what is the unit of velocity? Meter per second. And now let us look on to acceleration. Acceleration is the rate of change of velocity with time. Okay. So what is the formula of acceleration? A is equal to A represents acceleration and delta V divided by delta T, right? Because the rate of change of velocity with respect to time. And what is the unit of acceleration? Meter per second square. So this is the basic foundation of the chapter. And if you understand this, then only you can understand the further concepts, okay? And that is why I have explained what is displacement, velocity, and acceleration. Now let us see what is force, okay? And now a major question, okay? What causes acceleration? The answer is force causes acceleration. Okay. For example, kick a football, it will move. If you push a trolley, it accelerates. If you pull a door, it opens. If you apply a brake, vehicle will slow down. So force can stop, start, change the speed and also change the direction. But scientists once had a major doubt that does a moving object require force continuously to keep moving? So actually this question changed the history of science. Okay. I'll fasten this theory and etc. And I'll be telling you all the important definitions along the formulas, derivations in the coming topics. Okay. Now, Aristotle's fallacy. So Aristotle is ancient Greek philosopher. Aristotle, he believed that a force is necessary to keep a body in motion. This sounds correct because if you push a toy, it moves. If you stop pushing it, it stops. So Aristotle concluded motion needs continuous force, but there was one hidden force he failed to understand was friction. Okay? Now, the toy car stops not because of the force disappear, because of the friction opposes the motion. So if friction were absent, the toy car would continue to move. And this mistake delayed scientific progress for nearly 2000 years. Okay. And now, Galileo and law of inertia. Galileo is also like Aristotle, like he performed experiments using inclined planes. Okay. Now, what are his observations? I'll write his observations now. Okay. Now, what are his observations? Object moving down an incline accelerates. And what is his Another observation, object moving up will slow down. Okay. And object moving on smooth horizontal surface, continuous motion. Okay. Okay. I will actually explain all of these with applications. Okay. Object moving down an incline accelerates. What does that mean? An object is placed on a slope. A component of its weight acts along the incline. So gravity will pull it downward, causing its speed to increase. Okay, therefore, the object accelerates while moving down the incline. And now, object moving up will slow down because when an object is pushed up on the slope, gravity acts in an opposite direction to its motion. So, gravitational component opposes the motion and reduces the speed. And that is why object moving up is slowing down. And the next one, object moving on a smooth horizontal surface continues to motion. Why? On a perfectly smooth horizontal surface, like in this case, it is frictionless surface. Okay. So, no unbalanced force will act on the object. Gravity and the normal reaction cancel each other vertically, and there is no friction to oppose motion. And if a body continues in a state of rest or uniform motion in a straight line, unless acted upon by an external force, so now here Galileo has confirmed that a body once moving will continue moving forever with constant velocity if no force acts on it. And this property is called inertia. Okay? And now what's the definition of inertia? The tendency of a body to resist change in its state. Okay. Now, there are three types of inertia. A body resists starting motion, stopping motion, and changing direction. And that is a state where we are calling it as inertia. Inertia is the tendency of a body to resist change in its state. Okay. Now, let us see the type of inertia. Okay. Inertia of rest, inertia of motion, and inertia of direction. So, what does the inertia of rest mean? A body at rest tends to remain at rest. Okay. So, for example, I have taken here dust in carpet. What does it mean? The dust particles in the carpet will not come out unless it is beaten or it is like dusted, whatever. Okay. And next, inertia of motion. A body tends to continue to moving. If passenger falls forward when bus stops accidentally, and that is inertia of motion. Okay. And a body resists change in the direction, like passenger during the sharp turn. When there is a road like a sharp U-turn or an hairpin bend that you have to take in the car or in the bus, the passenger will move sideways during the sharp turn, like along with the vehicle. Okay. So that is called as inertia of direction. Newton's first law of motion. Done. Newton converted Galileo's idea into a law. Okay. Now, what is the first law of motion? Every body will continue in its state of rest or uniform motion in a straight line unless acted upon by an external force. I have written the definition here. What is the definition? If no net external force acts, there is no acceleration. What does that mean? Every body continues in its state of rest or uniform motion in a straight line unless something like an external force acts on that particular body. So, what is the formula of that if there is no net force? If net force is equal to zero, then automatically acceleration will be zero. How? F is equal to ma. That is a formula of force. Now we have declared F as 0, and obviously here A is equal to 0. And now this is the first law of Newton. And what is the second law? And before that, we have to understand an important idea. What is net force? Okay? An object may experience many forces, but motion depends only on the net force. For example, book resting on a table. Okay? Like this is the book that rests on the table. Weight acts downwards. Actually, the weight will act downwards, right? This is the table and this is the book. If I have placed it like this, the weight will act on the downwards. Now, normal force acts for upwards. So, both will cancel each other and therefore, net force is equal to 0. So, now the book will remain at rest. Okay? And let us apply the first law in our real life. Okay? When car stops suddenly, body continues moving due to inertia. Seatbelt applies force and stops the body safely. This is the first application. What is the second application? Shaking a tree. If you want some fruit from a tree and you are shaking the tree moves suddenly and whatever the fruit it is, for example, let us take mango, okay? Mango tends to remain at rest. So it falls. Okay, so this is the first law. And what is the second law? First law explains motion when force is zero, and second law explains motion when force acts. Okay, and Newton introduced a quantity here called momentum. Now, what is momentum? Momentum is nothing but the product of mass and velocity. And momentum is represented as p. This is the formula of momentum. What is the unit of momentum? Kilogram meter per second. Okay, and it is a vector quantity. And now, what happens when mass increases? The greater the mass, the greater the momentum. And the greater the speed, the greater the momentum. Now, let's take an example. A truck has more momentum than bicycle, and fast bullet has huge momentum despite small mass. Okay, and now, what is the statement of the second law? The rate of change of momentum is directly proportional to applied force and occurs in the direction of force. And what does that mean? They have mentioned that the rate of change of momentum is directly proportional to the applied force and the direction of the force, right? And now we will be taking the formula of F is directly proportional to momentum and time. Okay, and F is equal to dp by dt, that is delta p divided by delta t. So for constant mass, what is the momentum? Mass into velocity. Now we are going to apply the formula of momentum into the formula of the second law. So F is equal to delta of mv divided by dt. Now we will be taking m outside because m is constant. We have mentioned here now, constant mass. So F is equal to m delta v by delta t. So therefore, what is dv by dt? That is acceleration. Now what is the answer? F is equal to ma. And what is the SI unit? 1 Newton. What is 1 Newton? 1 kilogram meter per second square. Okay. And now let me explain the SI unit. 1 Newton. So 1 Newton is the force required to produce acceleration of 1 meter per second square in a 1 kg mass. Okay. And now there are some important points about second law. What are all those? Force and acceleration are vectors. So direction of acceleration is equal to the direction of force. Okay. Yes. Now, greater force will lead to greater acceleration. For example, if you push the trolley harder, what it will happen? It will accelerate more, right? Yes. And greater mass will lead to smaller acceleration because truck will accelerate less than bike for the same force. Why? Because the mass of the truck is greater than the mass of the bike. And what is impulse? Sometimes large force acts for very short time. Okay, like if you hit a ball or hammer hitting nail and airbag deployment, all of these involves impulse in it. So what is the formula of impulse force? Impulse is represented as J. Okay. So what is the impulse defined as? J is equal to F delta T. Okay. And it is also known as delta P. Okay. So therefore, I have mentioned here F delta T is equal to delta P. So what is the unit? Newton second. Okay. Now answer a question. Why cricketers move hands backwards? Then catching a ball, momentum change is fixed. So increasing stopping time reduces the force. So from that, what is the formula of F delta P divided by delta T? And we have to know another thing, that is greater time is representing that only smaller force acted on that particular body. So hence experienced cricketers move hands backwards. Okay. And what is the unit? Unit is kg meter per second. So we already know that 1 Newton is equal to what? 1 Newton is equal to 1 kg meter per second square. And now we have included second here. And if I have to say it, so this is how we have obtained the formula. Okay. And what is the third law of motion? So Newton has discovered that forces will always occur in packs. I think this is the favorite law of every 11th, 12th students because no one will forget once they heard of the statement. To every action, there is an equal and opposite reaction. Okay? And what is the mathematical form of the particular statement? F of AB is equal to minus F of BA. Okay. So here we have to keep few important points in your mind, that is action and reaction act on different bodies. They are equal in magnitude, opposite in direction and simultaneous in nature. Okay. And examples of third law. What are the examples of third law? Here walking. Foot pushes ground backwards. Ground will push your body forward. And let's take a very good example, swimming. So you will be pushing the water backward and water pushes the swimmer forward. Okay. And actually there is a misconception between what is an action and reaction. And actually people do think that action and reaction do cancel each other. Actually they do not cancel each other because they act on different bodies. Right? I have mentioned here now, if you swim, water will act on the swimmer and swimmer will act on the water. So there is in different bodies, right? Okay. If you actually start learning with the examples, it will be very easy to keep the terms in your mind. Okay. So now let's move on to law of conservation of momentum. Okay. Now we will be using Newton's law here. Okay. Now, I have mentioned here the total momentum of an isolated body will remain constant if no external force acts on it. So, what does that mean? Momentum before the interaction will be equal to momentum after the interaction. So, by the formulas, we will be seeing that what is formula that I have given here? M1 U1 plus M2 U2 will be equal to M1 V1 plus M2 V2. So what does that M, U and V mean? So M1 and M2 is the mass of two bodies. that we are naming it as M1 and M2. Okay, what is U1 and U2? They are initial velocities of the body of M1 and M2. Okay, and what is V1 and what is V2? The final velocity. Understand? Yes. And the examples of momentum I'll be telling you. Okay, let us take gun recoil as an example of momentum. So initially the total momentum will be 0, and after firing the bullet will move forward and gun will move backward, but momentum will be remain conserved. Okay, and what happens during the collision? During collision, momentum is always conserved, and kinetic energy may or may not be conserved. Okay, let us take collision of balls. When two billiard balls collide, the momentum before and after the collision will remain same. Okay. So what are the examples that we have considered? Gun recoil and collision. I have told the collision of balls, right? So in all these cases, momentum will be conserved. So total momentum will remain constant. Before and after the collision, momentum will be same. And now equilibrium of a particle. So let me first tell you what is equilibrium. A body is said to be in equilibrium when the net force acting on it is zero. So the net force should be zero in equilibrium. So this means all the force acting on the body balance each other. Okay? And there are few types of equilibrium: static, dynamic, and rotational equilibrium and all. Okay, what is static? I'll be explaining you each in a shorter way I can. Okay. So what is static? Static equilibrium is the body at rest and remains at rest. Okay. For example, the book lying on the table. I have already told you that the weight will act on the downwards and normal reaction or tension acts on the upwards. So both cancel see each other and the net force will be zero. In 2D also, Fx and summation of Fy will be 0. And before moving on to that, what is dynamic equilibrium? I'll tell you that too. Okay. So the body moves with constant velocity. And in that case, it is said to be dynamic equilibrium. Okay, a car moving on a straight road with constant speed, or a train moving uniformly on a straight track, all of these comes under dynamic equilibrium. And now what is rotational equilibrium? And for a body not to rotate, the net torque must be 0. If a body should not rotate, the net torque must be 0. Okay? And this symbol means torque. Now, conditions for complete equilibrium is the net force should be 0 and the net torque should be 0. Okay, let me explain in another example. That is, Caesar balanced at the center, or a person standing still. All of these are the example of equilibrium. And now, if I have to tell the exact definition of equilibrium, I'll be writing here. Okay? Equilibrium is the state of a body in which the resultant of all force acting on it is 0, and hence the body will be at rest or moving at constant velocity. So I have mentioned a trick here to solve a problem. So if you get any important topics from mechanics, for the first thing you have to do is isolate the body. Like, for example, they have mentioned A or B, whatever. The A is the body that you're going to take first and draw all external forces. What are all the forces that is acting on that particular body? You have to draw all of those and resolve force into components and apply Newton's law on that. Okay. And now let us see some common important forces. Okay. I have mentioned gravitational force, normal reaction, tension, friction, and spring force here. First, let us see what is normal force. What is normal force? Force exerted perpendicular to the surface. So, the table pushing the book upwards, or else if you're, we can imagine this as a table, and yeah, this is the table. Okay. And here I have kept a bottle. Okay. And this bottle is actually perpendicular to the surface of the table. Okay. Now, what is tension? Force transmitted through string or rope. Okay, the direction of the tension will always be away from the body along the string. Okay, yes. Now, what is spring force? In this particular topic, there is a law called Hooke's law. Hooke's law explains that if an extension or compression has acted on an elastic body, this will be directly proportional to the force applied. Okay. And what does that mean? If the compression or the extension is double, also the force will be double. If the extension or compression is triple, the force will also be triple. Okay, now what is the formula of Hooke's law? F is equal to minus kx. What is k and what is x here? K is spring constant and x is the displacement. Okay, and here the negative symbol mentions the restoring energy. Now, let us see what is friction. So, friction will actually oppose the relative motion. Okay, yes. Now, without friction, walking is impossible, brakes will fail, and vehicles cannot move. Okay, what are the types of friction? One is static and another one is kinetic. What is static? Acts before the motion starts, and kinetic will act after the motion starts. Now, laws of friction. So, at the state of maximum static friction, what is the formula? Mu Sn. And at the state of kinetic friction, what is the formula? Fk is equal to mu k n. Now, what is the mu s, mu k, and n represents? So, mu s represents the coefficient of static friction. Okay, and mu k represents the coefficient of kinetic friction. And what does the N mean? That is normal reaction. Now, usually kinetic energy will be less than the static energy. Okay, now what is the unit? Unit is N. What does that N mean? Newton. So, the coefficient of friction is mu is equal to force divided by N. F is friction force and N is normal reaction force. Okay. Now, what is angle of repose? When a body is just about to slide on the inclined plane. Okay, this is the body A. It is going to slide on the inclined plane. So, I have explained you already what is angle of repose. The angle of repose is the maximum angle of inclination of a plane with the horizontal at which a body placed on it is just about to slide down. right? And at this angle, the limited friction acts on the body. Okay? Yes. And now what is the formula of angle of repose? Mu s is equal to tan theta. Okay? And mu s is the coefficient of static force and theta is angle of repose. Now, if we need to find the value of theta, it is equal to tan inverse of coefficient of static force. So, at the angle of repose, force static friction is equal to coefficient of static friction into n. And here mg sin theta is the formula of Fs and mg cos theta is the formula of n. And now if we apply in this main equation, what is the answer? Mg sin theta is equal to mu s mg cos theta. And if we keep mu s on this side and I'm bringing mg cos theta on the other side, so mg gets cancelled, sin theta by cos theta is equal to tan theta. And that is how we are obtaining the angle of repose formula. Okay. Another concept here, what is rolling friction? Okay. What is rolling friction? Actually, rolling friction is much smaller than the sliding friction. Okay, so therefore, wheels will have to put very small amount of effort and the ball bearings in the machine will reduce friction. And now let's move on to circular motion. So any body moving in a circle requires inward force and that force is called as centripetal force. Now what is the formula of centripetal force? Fc is equal to mv square by r. What does the m mean? Mass. And v means speed. R represents radius of the circular path. So what is the direction? It has to move towards the center of the circle. What's the example of centripetal force? Tension in a string and gravity in the planet and friction for vehicles. All of these are the examples of centripetal force. Okay, I will write down the examples here. Yeah, and now, and before that, let us learn what is centripetal acceleration. Okay, centripetal acceleration is represented as AC here. And what is the formula of acceleration? V square by R. And you can also replace it as we already know F is equal to MA and A means V square by R and M is M here. Now, let us take an example of vehicle on level road. Okay. So, for circular motion, friction produces centripetal force, right? And what is the formula? Like the maximum safer speed would be void. Now, we already know the formula of the centripetal force, that is F is equal to mv square by r. And the maximum safer speed, that is maximum friction, is F max is equal to mu mg. What is m, g and mu means? Mu means coefficient of friction, r means the radius of the road and g means acceleration due to gravity. Okay, and have substituted F max as mv square by r and m will get cancelled. And now you will be getting the formula as what? V square is equal to mu r and g. We can also write it as P is equal to square root of mu R and G. Okay. And it is a maximum safer speed. And mu is nothing but the coefficient of friction. And banking of roads. Okay. The roads are tilted inward on the curves. Yes, right? The roads will be actually tilted inwards on the curves. So advantages of these are less dependence on friction and greater safe speed. Okay, what is the optimum speed that is okay on these kind of roads? That is V is equal to square root of Rg tan theta. Okay, R represents the radius of the road and G represents acceleration due to gravity and theta represents the banking angle. Okay, and now what is the banking condition here? So tan theta is equal to the same formula. Tan theta is equal to, let us write it like this. Okay. Now, what is tan theta here? V square by Rg. That's what I have mentioned here. Now, from this formula, we can also obtain V. What is V? That is what we have obtained here. Okay, V square is equal to Rg tan theta and V is equal to root of Rg tan theta. I have already told you to solve the problems in mechanics. Step 1, draw the diagram, identify the force, draw free body diagram, resolve the forces and apply Newton's law. Okay? Yes. Now, let me summarize the entire formulas alone. Okay? Now, what is formula of momentum? I'll be mentioning it as P. Okay? mv. And Newton's second law is F is equal to ma. And what is impulse? Impulse is J, right? Yes. F delta T is equal to delta P. Now, what is the formula of friction? F is equal to mu by N, right? And what is the Hooke's law? F is equal to minus Kx. What is this negative energy represents? The restoration force. And now what is the centripetal force? Fc is equal to mv square by r. And the maximum safe speed formula, Vmax is equal to square root of mu rg. And banking of roads formula, D is equal to square root of rg tan theta. Now, okay guys, with this I'll be completing this chapter and the next video will be the problem solving session for the same chapter. So I request you not to miss it because we will be solving the previous year questions along with the most important questions. So stay tuned, subscribe and support my channel. Bye, take care.